Welcome back to Advent of Code Day 3, 2021. Today is getting a bit more challenging than the previous days. That's perfect. I'm gonna try to make it. So today we have a list of binary numbers. So as always, I'm just taking the binary numbers, placing them in my file. I'm taking the code that is used to read the input from the previous day, and I'm updating it for today. Here, what I was thinking at first is just to pass the number in base 2 so that we have a list of integers. But the problem is that we need to access each bit separately. So we're just going to get rid of the parsing and we just use a list of strings. So now the most obvious thing to do would be to just do for of line of lines, and here I'm doing something with the line. What do we want to do exactly? We need to compute the gamma rate and the epsilon rate, and for that we need to find the most common bit in the corresponding position, and I think also the least common one, right? Epsilon rate is the least common bit for each position. So we need to find the most common bit and the least common bit. So basically, for each position, we're gonna need to count the number of zeros and the numbers of ones. So first of all, we need the length of the number of digits. So length is the number of digits, and here we're going to say const ones. We're just going to do an array of length, and we're going to fill with zeros. Oops, sorry. And here we're going to say twos. We're going to just do the same. So basically here we have an array that counts the number of zeros in each of the positions. So basically in ones, after this number we would have this here would be 11011. I hope this is clear. I think with the code that I'm going to write it's going to be a bit clearer. So here we want to go for each position in the string. So we're just going to say const digits or bits line. So here I'm using some JavaScript syntax in order to split the string into an array of characters. And we're just going to do another for of. Actually, we're not going to do a for of. We're going to do a for each, and the reason is we both want the bit and the index. Yeah. Exactly. And now we're going to say if the bit is equal to 0, so here that's going to be that. If the bit is equal to 0, then we say ones of index plus plus, otherwise twos. Wait, actually it's zeros and ones. I don't know why. Yeah, binary is just zeros and ones. There is no twos. Okay, so now we're just going to log the zeros and ones. Node, we are day 3.js. So if we just take the first column, we have 1, 2, 3, 4, 5 zeros and 1, 2, 3, 4, 5, 6, 7 ones. 5 and 7, so we are good. So now that we have this, we need to create a number. Let's check the definition for the gamma rate, the most common bit in the corresponding position. So basically we need to do a for loop I and between 0 and the length of the number. And here we need to say const actually so here we need to create the bits. So const, let's actually say gamma rate. So for the gamma rate, here we say if zeros of I is more than ones of I, in that case let bit is 0 except if ones is bigger than zeros, then bit is 1. So we just say, okay, in the gamma rate the first bit is 0 except if there are more ones than zeros. That's it. So here we have our bit, and we're gonna say gamma rate, let's make that a string for now. Gamma rate of gamma rate plus equal bit. Now we can display the gamma rate. I think actually that looks 10110. And actually here we need to parse int this into base 2, that we convert this string into an integer. It's 22. Let's see, what do they say here? 22, the gamma rate is 22. So we have the good solution for the gamma rate. We need the same for the other rate. I think, yeah, I'm not really happy about that. Maybe it's time to make the code a bit cleaner, you know, have like a clean function. So yeah, so what I usually like to do is to copy paste the code at least once. When there are 2 versions of the code, that's fine, you know. When there are 3 versions of the same code, you need to rework things so that they are correct. So here I just we say the number of bits. So sorry, let's take from the definition. Definition of the epsilon rate is the least common bit from each position. So the least common bit, it's 0 unless there are more zeros than ones. In that case, that would be 1. So if there are too many zeros, then the least common bit is 1, otherwise it is just 0. And we can do the same here. Parse int epsilon rate base 2. So here I'm going the slow way. It is 9, and I believe, yeah, it's 9. So here we just have to multiply the number by the other one, and we have the same number here. So that's perfect. So now we can take the very big input. Oh, one thing I need to mention is that it's really important to go through each line just once. Otherwise, the complexity might be a bit too big. Yeah, that's one thing that's important. Let me know if you want me to dive in the complexity explanation, but that's one thing that's key. And we're good for part 1. Yes, let's dive into part 2, and I will read this offline for a second. Okay, before diving into part 2, I just want to make a small optimization, because here I'm doing twice the same thing here, and I don't like it, because basically epsilon is just the opposite of gamma. So here we should say bit is equal to 1. If so, we return 0, otherwise we return 1. Let's just try to make sure this is the same output. Yes, this is the same output. Yeah, that's just very small change, and here we're gonna make some comments as well. Most common bit, least common bits. Okay, that I've just seen that part 2 is reusing this code, so yeah, it's better to have something solid. Let me dive back into part 2. Okay, part 2, the problem statement for part 2 is quite hard. There is a lot of text, but actually it is not that complex. But yeah, like that's just, you need to hold on to read everything. So yeah, we have live support rating. The live support rating is so we're gonna make some comments in the code. For part 2, we have live support rating is equal to oxygen times CO2. So, and we need to define those two. I think it's always good to write some comments in the code because that makes everything just so much simpler then. And the oxygen generator rating, we need the most common, and this is the least common. So that's from the problem statement, that's what's interesting. Yeah, I mean, everything is interesting, but that's the most critical part. Now, what we need to write is a function. I'm going to write a function because I'm thinking I'm going to be using recursion for that. So function filter, I'm just going to say get oxygen rating, and here we want the lines, and we want the index. So basically, we're going to say const oxygen rating is equal get oxygen rating lines. And here we're going to say just index equal 0. We start at 0. So what we need to do is we need to filter everything. So we need to filter the line to make sure the most common value it has the most common value in the current bit position. So we're going to say lines that filter line. Here line of index should be equal to the most common bits is gamma. So that's why it was really important to write a little comment here. To gamma rate of I. Gamma rate of index, sorry. So const filtered. I'm not very inspired for the variable naming filtered. And here we're just going to be logging the oxygen rating. Can I spell well? And I think we're going to be back to this input because things are getting more complex. So we want to start with the small input, make sure everything is working perfectly, and then go to the next step. Okay, so the problem is, so let's see actually what they describe. In the oxygen, we start with 12 numbers and then keep the 7 numbers with a 1 in their position. So here 1, 2, 3, 4, 5, 6, 7. So we are good. We have kept 7 numbers. And here we need to say if filtered is equal filtered.length is equal to 1, return filtered of 0. So basically, if there is just, so what they say here is you need to filter with the specific bit criteria, and if there is just one number, okay, that's it. If there are more numbers, you repeat the process with the next bit to the right. So basically here we're going to be doing repeating the process with the next bit to the right, and here we are just using the same function, and yeah, I think that should be it. We're going to say here filtered, and here we're going to say index plus 1. So basically we are filtering according to a specific bit criteria. If there's just one element left, we return. Otherwise, we return the same function with the filtered set and the next index. And that should be a recursion that is working fine. Okay, this is not working fine because I have like 7 things here. That doesn't look right. So usually in the recursion, when you don't really know what's happening, the good thing is to display here that the function is being called. Maybe just like a small thing that I missed. Also here we're going to make the terminal a bit bigger. Let's see. Oh, actually, looks like it's working. We get a number in the end. Maybe I didn't save this. Let me try that to run that again. Okay, I think I didn't save the file. So this is it working? We have 10, 110. Let's see. 10, 110, which is 23. So we are good. The oxygen generator rating is correct. Now we have to do the same thing with, so we're just going to be copy pasting the CO2 scrubber rating. So we're just going to write CO2 here. Okay, same here. CO2 rating, and here we need to display the CO2 rating. Let's make sure this is correct. We get the same number because I didn't change anything here, and here we don't want to compare with the gamma rate, which is the most common bit. We want to compare with the epsilon rate, which is the least common bit. We get 0, 1, 0, 10. So this is correct. So we're good. We just have to do like previously, pass these strings from base 2 to a decimal number and multiply them together, and we should have our number, which is 220. Oh, I think there is something wrong. Oh, multiply the oxygen generator rating by the CO2 to get that. 230. I get 220. So that's interesting. Looks like something went wrong. Oxygen. Let's try to display again. 2 things. Or let's. I'm displaying. Wait, 22, is it? Oh, it should be 23. So I thought it was correct, but it is not correct. So we have a mistake in our oxygen generator rating. Here, the CO2 rating is fine, but the oxygen rating isn't fine. So, like previously, I told you when there's a problem in a recursion, the good thing is to just display the input of the function. I also like to put the name of the function just to make sure I'm not mixing things together. So at first we have a lot of numbers, then we have just 1, 2, 3, 4, 5, 6, 7 numbers. Then we have just, at the end we have just 2 numbers. Let's not do like every step. At the end we have just 2 numbers, which is 10, 110, and okay, so this is correct. There are an equal number of, oh wow, there is an equal number of 0 bits and 1 bits. That's annoying. The good thing is that I have the zeros and ones here. So I can say, I have to rewrite that, because if there is an equal number, so that's a good thing. If there's an equal number of both, we should use 1. Is that correct? So, okay. In case of the oxygen generator rating, if there's an equal number, it should be 1. Okay, so here we're gonna need to change that a bit. We need to say, we need to change that quite a lot. If ones of I is equal to zeros of I, then in that particular case, so basically we are creating a special case that's a tricky one, you know, that's a tricky one. So if there's the same number, for the gamma rate, we need to keep a 1. And for the epsilon rate, we need to keep a 0. Let's see that fixing part 1 should have fixed part 2. Let's see that is not correct. When you have a bug and you don't understand why you have this bug, I think I'm going to need to display the gamma rate here. Oh, I'm going to say gamma rate of index. So in that case, here we have a 0, so that shouldn't be a 0. Gamma rate of index. I think I made a mistake here. I'm not sure we should be using the gamma rate and everything. I'm gonna do a little bit of thinking. I think I found the problem. So what I'm doing is that here we're computing the most common bit and the least common bits for all lines. But here we want to get the most common bit and the least common bit for these lines that are being filtered. So for example, here you have 2 numbers. So you need to find the most common and least common bits out of these 2 numbers. So yeah, we're gonna have to do a bit of refactoring here. We're gonna say get, I don't know, get count of lines and basically that should be it. Get count, yes, yes, yes. Yes, that should be it. So here we're going to say part 1 so that we make sure we don't overlap with our variables, because that's just going to be messy otherwise, because I want to reuse the same variables in part 1 and part 2. So now we have this get count. So here const zeros, ones, get count of lines. And we call this part 1 here. Oh, everything exploded. Oh yeah, that's because of part 2 here. Here we're going to call that part 2 function, part 2, a little bit of refactoring. I understand why people were telling me this day is a bit more complex than the previous days. Yeah, actually, let's not call part 2 because we know there is like things to fix. We just want to make sure part 1 is working fine. 198, if I remember correctly, this is the right number. But now what changed is we have this get count, which is going to be super useful, because here we're going to say get count const zeros. Let me just copy this thing and here. What happens now is that we have the count of zeros and 1 only for the elements that have been filtered here. That's going to be a big deal because we don't want to use gamma rate. Actually, that's bad idea, bad idea. Instead, we want to say, okay, if I want to say const most is zeros of index is more than ones of index. In that case, we return 0. Otherwise, oh, this is going to be a bit messy. Let's do let must equal 1 by default, and we just say, okay, if there is more zeros index than ones of index, in that case, and that case only, we say must equal 0. Actually, I'm going to rename must because that's bad. Must common bit. And now, and only now, we can use this must common bit here. And what I want to do before trying this out is to fix this function. So we're going to do something similar. Here, this instead of the most common bit, this is the least common bit. And by default, it should be 0 unless there are more zeros than ones. In that case, this should be 1. I think it's fine. And here, instead of epsilon rate of index, we want the least common bit. Let's try this out. Forgot to uncomment running part 2 here. Now we have 23 and 10. I think we fixed the issue. Let's get the puzzle input. It didn't change, but I think it was very wise to try on the example instead of trying on the full input. Okay, so I have too many console logs. I don't like that. Okay, here I have so many console logs. To remove that, should be correct. Let's try this new number. I think we're good. Yes, we are good. Thank you so much for the support in this series. Please drop a like, a comment. It really helps a ton and it keeps me motivated to post this every day. Yeah, thank you very much and see you in the next one. Bye bye.